Hello, good morning. Quantum and statistical mechanics. Quantum. The smallest amount of many forms of energy, example light. Quantum physics. The branch of physics concerned with the quantum theory. Quantum physics allows the particles to be in the two states at the same time. Quantum chemistry, it is the application of the quantum mechanical principle and equation to the study of the molecules. Quantum mechanics, it is a science dealing with the behavior of matter and light on the atomic and subatomic level. In short, quantum mechanics is the science of very small, explain behavior of matter and its interaction with energy and the scale of atomic and subatomic particles. It attempts to describe and accounts for the properties of molecule, atoms, electrons, protons, and other particles, quarks, gluons. It always gives the probability of finding the particles at various locations. History of quantum mechanics, Max Planck's theory. The first breakthrough came in 19. Max Planck's introduced the concept of the quantum theory to explain the phenomenon of black body spectrum of light emitted by any heated object radiation. He succeeded in reproducing the experimental results only after postulating the energy exchange takes discrete, fixed, or quantized amount. He argued that energy exchange is E equal to hf, h equal to Planck's constant. Photoelectric effect in 1905, Einstein provided a powerful consolidation to Planck's quantum concept. In trying to understand the photoelectric effect, Einstein recognized that Planck's idea of quantization of electromagnetic waves must be valid for light as well. So following Planck's approach, he quoted that light itself is made of discrete bits of energy for teeny particles called photons, each energy hf. Atomic stability and atomic spectroscopy, Bohr's introduced 1990 and 1930, is model of hydrogen atom containing from Rutherford's experimental discovery of atomic nucleus in 1911, Planck's quantum concept and Einstein photon. In this work, he argued that atoms can be found only in discrete states of energy and that interaction of atoms with radiation, that is the emission or radiation by atoms, takes place only in discrete amounts of HF because it results from the transition of the states. This work provided a satisfactory explanation to several outstanding problems such as atomic stability and atomic spectroscopy. Wave source particles behavior at the microscopic scale in 1923, Compton made an important discovery that gave the most conclusive confirmation for the corpuscular light is formed by small particles, specks of light, by scattering X-ray with electrons. He confirmed that the X-ray photons behave like particles. This series of breakthroughs due to Planck's, Einstein, Bohr, and Compton gave both the theoretical foundation as well as conclusive experimental confirmation for the particles aspects of waves, that is the concept that wave shows particle behavior at the microscopic level. De-Brogli concept. De-Brogli introduced in 1923 another powerful concept that classical physics could not explain. He postulated that not only does the radiation exhibit particle-like behavior, but conversely material behavior themselves display waves-like behavior. This concept was confirmed experimentally in 1927 by Davison and Germer. They showed that interference patterns of property of waves can be obtained with material particles such as electrons. Heisenberg uncertainty principle and Schrödinger particle in 1925, Heisenberg developed the Heisenberg uncertainty principle. There were two independent formulations of quantum mechanics. The first formulation called matrix mechanics was developed by Heisenberg 1925 to discrete atomic structure starting from the observed lines. The second formulation called wave mechanics was due to Schrödinger 1926. It is generalization of De-Brogli postulates. This method is more intuitive than matrix mechanics, describe the dynamics of microscopic matter by means of equation called the Schrödinger equation instead of the matrix eigenvalue problem of Heisenberg-Schrödinger, obtain different equation, that is time independent and time dependent equation. The solution of this equation provides the energy spectrum and wave function of the system under consideration. Max-Born probabilistic interaction of wave mechanics in 1927, Max-Born proposed probabilistic interpretation of wave mechanics. He took the square moduli of wave function psi square that are the solution to the Schrödinger equation, and he interpreted them as probability densities. The approach of the Schrödinger and Heisenberg represent, respectively, the wave formulation and matrix formulation of the general theory of quantum mechanics, combining the special relativity with quantum mechanics. Dirac in 1928, an equation which describes the motion of the electron. In summary, quantum mechanics is the theory that describes of matter at the microscopic scale. In short, quantum mechanics is the founding basis of all physics, chemistry, and biology. Okay, it's all about history of quantum mechanics. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for facing. That is now. Bye bye. See you again.